Welcome. In today's video, we are going to be covering organic chemistry. So first, what is organic chemistry? Organic chemistry is the study of compounds which contain carbon. Compounds which contain carbon are called organic compounds. And what's so special about carbon is that carbon has 4 valence electrons. This means that it can form bonds with 4 other ions. This gives a wide variety of different compounds which can be formed. So before we jump right into it, there's a little term that I want you guys to get familiar with, and that is saturated and unsaturated. So a saturated organic compound is an organic compound. So a saturated organic compound is an organic compound in which the carbon atoms are joined together by a single bond and only by single bonds. An unsaturated organic compound is an organic compound in which the carbon atoms are joined together by double bonds. So like this. Allow me to add in the lines for the extra valence electrons. So right here, this would be a saturated organic compound and this would be an unsaturated organic compound. So let's take a look at one such organic compound. What we're going to look at is the most common one called methane. Methane has 1 carbon ion and 4 hydrogen ions. So there are many different organic compounds. So over here, we have ethane and down here, we have ethene. So many of you may be wondering, how is it that we name these compounds if there are so many? Well, there are just some standard conventions that we use when we name organic compounds. So we name organic compounds based off of 2 things. First is the number of carbon ions present within the compound and also the functional group of that compound. So what is a functional group? Basically, a functional group is just what gives the compound its chemical properties. And compounds which share the same functional group are called members of the same homologous series. I know all of that sounded a bit difficult, so the easiest way to understand it is to just get right into it. So first, let's take a look at alkanes. So with homologous series, they share a couple things. They first share a similar formula, which can be used to determine the number of hydrogen present. And they also share the same functional group as well as the same ending for each of those organic compounds. So let's take a look. Up here is the shared formula for alkane. So it says CnH2n plus 2. This might seem a little bit gibberish, but I can assure you it's very, very simple to understand. This just means that the number of hydrogen in relation to the number of carbon is that there's going to be 2 times the number of carbon plus 2 more hydrogen. So now we can take a look at over here. Over here is a member of the alkane group. And as you can see, there is 1 carbon and 1 times 2 is 2. So we know that there has to be at least 2 hydrogen. And then 2 plus 2, that's 4. So now we know that this is definitely a member of the alkane group because it has 2 times the number of carbon plus 2. So even though we know that it is a member of the alkane series, how would we name it? Well, in organic chemistry, we name members of the same homologous series based off of the number of carbon present. So we have a few prefixes which we use depending on the number of carbon present. So here are the prefixes we use and the corresponding number of carbon ions present within the organic compound. So looking at this table, let's try and name this compound. Right here, we have only 1 carbon ion present. So this means that it's going to start with meth. And we know that it's a member of the group alkane. So we know that it will definitely have the ending ane. So therefore, we're able to determine that this organic compound is a methane. Methane with the formula CH4. So now let's look at a different homologous series. So over here, we have the alkene series. So the formula for the alkene series is CnH2n. This basically just means that the number of hydrogen is always just going to be double the number of carbon. So we can see that over here where so there is 2 carbon. So that means there must be 4 hydrogen. The ending for the alkene group is ene. So now let's try and name this compound over here. There are 2 carbon ions present. So therefore we know that it must start with eth. And we know that the ending for the alkene group is ene. So we know now that this organic compound is ethene. So let's take a look at the functional group for alkenes. The functional group for an alkene is a double bond between two carbon ions. This means that this is always going to be present within every member of the alkene series. And we can see that over here in ethene, there are two carbons joined together by a double bond. The thing is, with the alkene group, there cannot be any such thing as methane because there needs to be a double bond between carbon ions, correct? This means that for it to be a member of the alkene group, there must be at least two carbon ions. Therefore, the simplest member of the alkene group is ethene. Now let's carry on. So right here, we have the alcohol series. The alcohol series has a shared formula of CnH2n plus 1. This means that the number of hydrogen in relation to the number of carbon is always going to be 2 times the number of carbon plus 1 extra hydrogen. On that formula, there is also the functional group. So let's take a look at over here. Let's try and name this compound. So there is 1 carbon. So we know that the prefix must be meth. And we know it's a member of the alcohol group. So therefore, this must be methanol. So now that we know this, let's take a step back and take a look at the functional group of alcohols. So the functional group of alcohol is just OH, a single bond between the O and the H. And we can see it over here in the methanol. But there's something that you need to take note of. When you're writing the formula, do not include this hydrogen outside of its functional group. Let's try and write the formula for this methanol. So we can see right here that it's 1 carbon and 3 hydrogen. So we're going to write that as CH3. And now we're going to write the functional group, which is OH. So this is the formula for methanol. You must never mix up this hydrogen right here. So do not write it as CH4O. This is so incorrect, you don't even understand. So now that we know this, let's carry on to the alkanoic acids. So the formula for an alkanoic acid is CnH2n plus 1. Just like the alcohols, there's going to be 2 times the number of carbon plus 1 hydrogen atom. And then we also have the functional group tacked on to the end. So this functional group is called the carboxyl group, where it is a carbon ion double bonded to one oxygen, another oxygen, and a hydrogen. So let's take a look at the simplest alkanoic acid. We can see that there is 1 carbon. So therefore, because it's a member of the alkanoic acid group, this would be methanoic acid. So once again, we have to pay attention to the formula when we write it. So this is methanoic acid, right? When we write the formula, we must always leave the functional group at the end. The functional group separate from all the other carbon and hydrogen ions. So therefore, for methanoic acid, we have the formula being HCOOH. But if we were to add on another carbon and make this into ethanoic acid, we'd have it as CH3COOH. So with all of that being said, that was it for today's video. The next video on this topic will cover isomerism. So if you are interested in that, I would suggest that if you see it on the screen right now, please do click on it. And if you don't, just check the playlist. It will definitely be there. So thank you for watching and bye bye.